Hello guys, so in this video we are going to discuss the solution for maximize the topmost element after k moves uh, of weekly contest of LeetCode. So in this problem we are given an array, zero indexed array representing a contents of pile, and the zeroth indexed element is the topmost element of the pile, and we have given k integer k, so we can do k moves, and in this moves we can either, if the pile is not empty, then we can either remove the topmost element, and if the pile is empty, uh, no sorry if the pile is not empty, then we can remove the topmost element, and if we have removed more than one or more than one elements, then we can add any element back to the pile. So this element becomes the new topmost element, and we have to maximize the topmost element of the pile after exactly k moves, and if it is not possible to obtain a non-empty pile, then we have to return -1. And let's see this example here. In this example we have given this array and k equal to 4. So what we can do is, first remove 5, then 2, then again 2, and then add 5 again. Or we can either do this also, that remove 5, then add 5 again, then remove 5 again and add 5 again. So this will also work. So the condition is only that we have to make k moves, exactly k moves. In this case we have k equal to 1, so we have to remove 2, and if we remove 2, the nums array becomes empty, and if it is empty we have to return -1. And the length of the nums array is 10⁵, so we have to do it in n or n log n. So what we can do, we can create cases. So if k equal to 0, they are given that k can also be 0, and if the k is 0, then we have to just print the first element of the array, because we cannot do anything. If k is odd and the numbers array contains only one element, then we have to output -1, because what will happen if here k is equal to 3, if we take here k is equal to 3, and what will we do is remove this 2, then again add this 2, then again remove this 2. So finally the nums array will become empty. So this is one condition. Then there are more 3 conditions, that if the k is greater than the nums array, if the size of the nums array, if this happens, then what we can achieve anything. So we can remove all the elements, then again add one element. Like if the maximum element, we have to print the maximum element if the k is greater than the size of nums. So let's take here, if k is equal to 7, if k is equal to 7, then we will remove all the elements and we will add only 6, then the topmost element becomes 6, which is maximum of the nums array. If k is 8, then we will remove all the elements and we will add first any element between any element of this 5, and then we will add 6, then again the topmost element is 6, which is maximum. And there is another case, if k is equal to n, so k is exactly equal to n, so we can't remove all the n elements. If that happens, we have to print -1, but we have to print maximum possible, so -1 is not maximum possible. So what we will do, we can only go till n-1. So how we can go till n-1? So we will remove all n-1 elements, and whichever element is maximum in this n-1 element, we will print that element. And there is another case, if the k is less than nums, which is here, which is happened here. So what we can do, we can remove we can use this k to remove all the elements. So if we remove all these elements, we will get only 0 at the topmost. Or we can use k minus 1 elements. So k minus 1 5 to 2, we can remove 5 to 2 and add the maximum element in this 3 elements, or k minus 1 elements. Okay, so now we will code uh, for this. So first we will initialize integer n as the size of the nums array, and what we'll do is int answer equals to -1. So if the answer is not possible, then it will automatically return -1. Then we will write each case, like k is equal to 0. If k happens to be 0, then we have to return the first element, because there is no other option. We can't do any move. Else if the k is odd and n is also equal to 1, then and only then we have to return -1. So answer is -1, so it will be returned. And else if the k is greater than n, then we have to just output for the maximum. So int or let's say we will do a for loop and just maximize the answer equal to maximum of answer and ar, or sorry, nums of I. Else if again for k equal to n, if this happens, uh, then we have to do the same thing, but uh, here we can go only till k n minus 1, because as I have explained that we can't remove all the elements, because answer will become 0 then, and which is not possible. And if these conditions, all conditions are not true, only k is less than n, then we will do a for loop int I equals to 0 and I equals to 0, I is less than k minus 1. We will go till k minus 1. So as I have explained in this, we will go till k minus 1. So k is 4, we will go till this k minus 1, and we will again add maximum removed element to the pile. So we can only go till k minus 1, and we will check for the answer equal to answer maximum of answer and nums I. But we have one more case, that what if we remove all elements, all k elements, so all the first k elements, and what if this is the maximum, this 0? If we assume that here is 10, then we have to output 10, right? Because we can remove all the elements, all the 4 elements, and output 10. So for that we can do answer equal to maximum of answer and nums I plus 1, because our I stopped here on the k when the condition is made that k is equal to I, and we have to find the maximum of these. So, and we will then return answer. So let's use all the sample test cases and run the code first. Yeah, so they match, the answer matches, so we will submit it. Yeah, so as you can see, the solution is accepted. If you understand the solution, then please like the video and subscribe. Thank you.